I'm Safillah Timrian. I came from Afghanistan. I am early stage researcher number 10. My research project is between University of Naples Federico II and University of Franche-Comté in France. Periodic structures. Periodic structures are made of series of elements or cells which is periodically repeated in a regular space interval. Structural periodic design is a powerful strategy for lightweight structures achievements while remaining convenient solution for manufacturing guideline aspects. Periodic media exhibits dynamic filtering effects, which can be smoothly used for vibroacoustic design. This is an example of periodic structures, which you can see these series of cells are perfectly periodically repeated, and the rest of the cells on the left hand side, you can see that there are some defects on this series of cells which is repeated. So there is a quasi-periodicity and variability effects inside the patterns of these periodic structures. This periodic structure is used to place inside the shell of the fuselage of aircraft. We have the outer skin and inner skin, and it's going to be attached on the inner skin of the aircraft in order to act as a good filter for structural dumping and to create a great acoustical transmission loss. In periodic structures, the definition of quasi-periodicity remains to be investigated in order to understand how this can be modeled. Quasi-periodicity is a property of material that displays irregular periodicity. My task of responsibility is to develop and to validate tools for the design of vibroacoustic treatments based on quasi-periodic patterns, allowing passive control of vibration and acoustic paths.
Numerical tools used in modeling quasi-periodic structures are development of codes based on MATLAB. For structural dynamic behavior of one-dimensional spring mass system, for forcing frequency response function, for using wave finite element method for wave characterization of periodic spring mass lattice. And also there is a usage of FEMAP and XNASTRAN software for model analysis of one-dimensional periodic spring mass chain and for mood shape analysis of periodic spring mass chain. The results are based on modeling quasi-periodic structures. 1. In quasi-periodicity, FFT results shows 3 regions of bandgap and finite periodic system, whereas in perfectly periodic structures with the same finite periodicity we get only 1 region of bandgap. Link between eigenfrequencies of finite system with dispersion curve shows the localized wave in inner and outer phase of the acoustic and optical branch, key element found in order to control the regions of bandgap. Future work will stand on construction of a one-dimensional periodic beam with deterministic and stochastic variables approach to fulfill the modeling strategy of quasi-periodicity and its effects on periodic media.